Okay. Yeah. Morning all. So before I start, can anyone please confirm whether my voice is clear, whether the screen is
Yeah,
visible or not?
your voice is clear.
Yes, fine. Thank you. So yesterday we had some introductory session in this. So I was talking about data science and AI. Excuse me. So in today's world, right, I was talking technology is growing very faster. Sorry, my throat is not well. Sorry for that.
But
Two of the
before you start, one question, like, yesterday you said the classes going forward is 8 o'clock, correct?
yes,
Okay, from next week onwards.
yes.
Okay, I requested the previous class to, have earlier to attend your classes. Yeah.
Okay, fine. So data analysis. So here in today's world, technology growing faster ever before, right? Most of the two of the most powerful fields today, right? Data science and AI. They're helping people to solve problems, making smart decisions, improving our daily lives, right? So data science, so everything deals with the data here. Data has got experience, data has got future reference. Using data science, we perform data analysis, predictions, classifications, clustering, and recommendations, right? Yes. It's a blend of technique. Yes. So yeah. So here, this data has got experience and future reference. We perform like analysis, predictions, classifications. So data science combines math, statistics, programming, advanced analytics, artificial intelligence, machine learning for extracting insights hidden in the organization's data. In a shorter version, data science is the art of turning data into actions. Data science focus on value, not on volume. Data science emerged from statistics and data mining. So yes, so it is a the study of data. Data science is a study of data. It helps to collect, organize, understand the information. So the companies they use data science in various fields, like in business decision making. And not only that, here generally today, if you see, the companies have got lot of data. The companies have got lot of data, huge raw data available. So based on this raw data, you can extract useful insights and where the data science can help you in answering different questions like what the customers are expecting and how to improve the current services and what will be the trends, what will be the upcoming trends in the sales, and if you're performing any event, how much stock required, everything it is going to help you, right? Apart from that, it is used in various field in decision in business decision making, right? So I was talking about Amazon using data science for recommending the products based on this your browsing history or your purchasing history. It is also recommending, right? Or if you talk about the healthcare and medicine, it is helping the doctors in predicting the diseases in the earlier stages and improving the patient's outcomes, right? And in and predictive and this finance and banking and finance and banking, right? It is data science helping to detect the fraud and managing the risk and also personalizing the customer services. Media and entertainment, right? Media and entertainment also, we have got some kind of recommendation algorithms, right, to suggest movies, to suggest the movies or shows or songs. See, it is suggestions, some recommendations or suggestions given, right, based on to suggest the movies, shows or the songs based on the user interest. Weather forecasting and climate research, right? Yes, they're using data science to predict the weather patterns, analyzing the climate. Government and public policy, right? Yes, government and public policy. Yes, government and public policy, they use data in improving the public services, security, infrastructure planning, and even some traffic control, waste control, and energy utilizations, all this. E-commerce and customer experience, right? Online platforms, mainly if we talk about the online platforms, they rely on the data to enhance their experience, increasing their sales. Okay, so data, so just like from the available data, you are just trying to create some insights. Means data is like oil, and data science is like refined oil, right? Yes. Okay. Artificial intelligence, like developing systems that performs tasks that are similar to human intelligence, such as learning, problem solving, decision making. Generative AI, creating some new content or text or images or code or music by learning the patterns from the data. Agentic AI is making some kind of decisions, making decisions and executing multi-steps actions. Just in a simple way, generative AI creations, agentic AI is about actions and decision making. So here in this data science, if we talk, we have got a blend of techniques, so regression, classifications, clustering, recommendations, right? The main technique what we see here is the main technique what we see here in this data science. It's a blend of technique. The main technique what we see here is ML, machine learning. Machine learning. So just without entering into the technicals, in a simple, understandable way, I will just define it. Okay, I can say it is an approach. It is an approach where we provide data patterns, to an application, right? Or a system. It is an approach where we provide some data patterns to an application or a system based on the data patterns provided. The application or the system. Can predict in the automated fashion. So based on the data patterns provided, the application or the system can predict the things in the automated fashion. So generally, we go with historical patterns. Generally, we provide historical patterns. Taking two variables. For example, taking two variables. I'm just not going to enter into the technicals as of now, just as in to make you understand with basic idea about it. So for example, x is there, y is there. If x value 1, y value is 10. If x is 2, y is 20. X is 3, y is 30. If it is 4, it is 40. If it is 5, it is 50. Now, x and y values are provided. Now, the data is provided. Data is provided to the application. And it need to predict. For example, if x value is 29, what is y? If x value is 29, what is y?
290 based on the data provided.
Yeah, exactly. But here the model performs analysis and evaluates relation between x and y. Relation between x and y. What is the relation between x and y? Check it. What is the relation between x and y?
X equal to y multiplied 10.
Yes. So here I can say y is 10 times x. Can I say? Y is 10 times x. Can I say?
Yeah.
Yes. If x equal to 1, check it for all the input variables. For all the inputs, is it giving a correct output or not? If x value is 1, check it. Y equal to 10 of 1. Sorry. 10 it is providing. For example, if it is 2, 10 of 2, it is giving 20, right? It is giving 20. 10 of 3, if the input is 3, 30. So on. So on, right? 10 of 29. What is it? 290 it is provided. 290. Hence y value is 290. This is fine. This is a simple kind of simple prediction. Okay, this is fine. But check with this. This is a simple prediction. Example. Still complex. If one. Try to see the pattern. Try to say me. Everyone. Try to interact. X value is 2. X is 2. Y is 14. Try to understand this pattern. X is 3. What will be the Y? Sorry, it is 10 here. It's 10 here, not 20. Y equal to 18.
17. 18.
X equal to 4. What will be the Y value?
22.
Y will be 22. That's fine. If X equal to 5, Y will be
26.
This is fine. This is fine. Now, if X value is 500, if X value is 500, then what is Y? If X value is 500, then what is Y?
Oh, it should be. Yeah, it should be some some formula. We have to derive some formula.
If X value is 500, if X value is 5000, then what is Y?
Yeah, we have to delay y.
That's what. There should be some relation between
X
X and Y. If you get the relation, then you can get it. If you get the relation between X and Y, then you will be getting. In the previous example, you got the relation Y is 10 times X. The relation between, by seeing the pattern, if you observe this pattern based on the patterns, it has to evaluate and just to provide that relay. So here, X relation, X and Y, sorry. The model performs analysis and evaluates. If X value is 1, can I say, is it valid if I say like this? Y equal to 4 times X?
4 times y equal to 4 times x. No.
Is it valid? Actually,
No.
here, when X value is 1, why you need to get a 10? But you are getting 4 only, right?
Plus 6.
You are getting 4. I need to add how much? Plus
6.
6. Now you got a 10, right? Now, for example, check for all the inputs. It is not only for this. So y equal to 4 into 2, 8. Compulsory, I need to add plus 6. Whether are you getting 8 plus 6, 14? Are you getting the correct x? X is 2, y you got 14. If x equal to 3, x equal to 3, y equal to 4 into 3, 12 you got. Plus 6 you need to add every time. 18 you got. So when x equal to 3, y equal to 18, you got 1 second. For all the inputs, one last one, x equal to 4, y equal to 4 into 4, 16 plus 6, that is 22 you got. Now what is that relation you can give? Can I say 4x, always 4x plus 6? Always 4x plus 6. You got that. In the same way, I was asking, right? If x equal to 500, if x equal to 500, y equal to, try to say y equal to 4 into 500 plus 6. What is the output? This is the output. Okay. So here for the relation between x and y. So based on the pattern, right? Okay. Example 3, you can check. Here also, two variables I'm taking. Two variables. For example, two variables I'm taking, temperature is there, sales. Assume temperature I'm talking means this is a summer, temperature in summer, the sales of some product like cool drinks. Now observe, if temperature 27 degrees, sales 31K, 31,000. Say for example, temperature 29, sales increasing. If temperature increasing, sales increasing. If 29, 31, 31, 35K, 33, sales increasing, temperature increasing, sales increasing. Positive correlated, right? So in this way, the sense. This data I need to provide to the application. Application need to predict. If temperature equal to 28, or if temperature equal to 37, sales will be how much? Approximately around 39K, around 39K or 40K. Temperature increasing. Today temperature was 35. This was the sales. Tomorrow temperature is increasing. Tomorrow temperature is increasing. Temperature is 37. Sales will be more than 37, right? Greater than 39K. Understanding? So here, but if data is not provided, this data is not provided. So just saying tomorrow temperature is some 34. Try to say the sales. You cannot. You need to have some data, historical data, already some based on the data. You are just going to perform this kind of analysis from the existing data. From last 4 or 5 days, it is raining. What is your prediction about tomorrow? From last 5 days, Monday, Tuesday, Wednesday, Thursday, Friday, what is your prediction about Saturday? The historical data or previous history is saying that tomorrow also maximum there is a probability of raining. So based on the data, previous data, you are just going to predict it. Okay. So based on historical data, the model is going to get a trend. So based on the historical data, the model is going to get a trend. So here, most of the times, see, observe this example for in the problem solving. In problem solving, right? For example, take the
What
example of
happened if you did not give the complete model data? If you did not give the complete historical data, will it model will also understood and analyze the pattern and based on the existing
See,
uh,
one thing, one second. If you compulsory data has to be provided, you need to train it based on that. You're training the model by providing data. Compulsory data has to be provided. Then
but
only. And that too, you're talking data is a small data or it is a huge, bigger data set. If it is a small data, right, the prediction level won't be that much. Prediction level won't be that much. If it is a bigger data, if it a bigger data set, right, then the bigger that data, right, and the prediction level will be more. If
But
the
let's
small
say if you
data,
have a 1 million records in the data, okay,
mm, mm.
and I want to deploy the model on the 1 million records, okay, I cannot train the my model for 1 million records, correct? I can only take few records and train the model so that my model can predict with the when I deploy the
Yes,
model.
yes, the model can predict it. The model can, based on that, it will find the patterns. What is the pattern in your data? It will just identify it and it will just going to predict it.
Okay.
It will just going to identify. Means one more thing here, with small data, sometimes the predictions might go wrong, right? For example, I'm saying, for example, small data. For example, if you're taking only 3 records or 4 records, based on that, sometimes the prediction level won't be good, because I am asking what is the average weight of people of Hyderabad? What is the average weight of people of Hyderabad? Weight, and between the age group of 25 to 50. Between the age group of 25 to 50. Randomly, if you go to 3 people and if you're asking their weights, if all the 3 people are obese, like they have got above 90, 19, 90, 95, 96, like that, you cannot come to the conclusion that all the Hyderabad males have got the average weight above 90. So if you are taking some 100 samples or 500 people or 1,000, it will get more accurate, right? Model can do that. Some kind of statistical analysis will be done. But with 2 or 3 samples, if all the 3 people are very thin, if all the 3 people are like obese, so that's why if the data, if you have got more records, then the prediction level will be more, and the pattern can identify the pattern much better. For example, Titanic, Titanic ship. For example, to solve this problem, total passengers they are traveling. Total passengers, assume it is 1,000. Out of this, total dead 800. Total survived 100. Total dead 800. Total survived 100. What about the 100? Remaining 100? Unknown status. About the remaining 100, it is unknown status. Predict what happened to this 100. Predict what happened to this 100. So for example, dead, how many? 800. Will have some common features. Say X features. Means the people who are dead, I'm just all those, they have got some common features. Just I'm grouping them as X features. Survived, people who are survived, 100 people. Assume that will have some common features. Will have some common features. Say it as Y features. So the people who are dead has got some common features. People who are survived are some. So just I'm grouping them as X and Y features. Means their age, their fare, what they how they the many features are there. Using this X and Y features. Using this X and Y features. Train the model. Train the model. Model will predict an unknown status. Unknown status. For example, unknown 100. Out of this 90 I've got X features. 90 people have got X features. Then I've got Y features. Means the history is saying that people with the X features, right? They are dead. This is a label label is given. That label given is dead. And the people with Y features, people who has got Y features, the previous history or the data is saying that people with Y features should have been survived. Survived. So just based on this X and Y features, you can say. So 90 people out of this 100 unknown status, 90 people have got X features. X features it's clearly saying that they are dead. And people 10 have got Y features. People with Y features clearly saying that they should have been survived. Okay. Based on this, right? Just check with one more example. For example, bank loans. Bank.
What is this called? Is that is there any specific name for this training this model called regression linear some kind of any machine learning? Is there any is there any term which you are using X and Y coordinates, X and Y um, formula derived?
See, we got features and labels, we say. Based on the input features, we need to predict the label. Say, we got depending upon the data, right? Which technique to be used, which will give which prediction level. The prediction level will be more. We need to see depending upon the data we got. You may ask, there are many techniques available. Regressions are available, classification are there, clusterings are there. Again, in that regression, again many are there. Linear, non-linear, again in classification, logistic regression, decision trees, random forest. In this way, many are there. So it all depends upon the data, right? For the data, which one gives, right? For categorical data, for numerical data, right? Which algorithm we need to go, that will be decided. So we have got many techniques. You may ask why not one or two, but we have got many are there depending upon the type of data. For different types of data, which one to be used, later I'll be discussing it. But here just bank provided loans to 1,000 customers, out of which, for example, 600 they're paying regularly. They're paying regularly. The people who are paying regularly, assume that they have got some X features. People who are paying that loans regularly, they've got some X features. I'm just grouping many features. Not this X means not a single feature, multiple features. Their age, their income, the salary, everything. And around this 400, they are not paying the loans regularly. They are not paying. We say them as defaulters. I've got Y features. So based on this X and Y, X and X means not a single feature, many features taken into consideration, input variables. For example, tomorrow some 100 new customers approached. See, we say train set. Just now you are asking, right? What do you say? Like we get train set, validation set, and test set. We say train set, the set which is used for the training, right? Test set on the test on which you are going to apply that test. Test set will be there, train set will be there, validation set is there. Later I discuss about those. So yes, three types of data sets we see. 100 new customers approached. What is the prediction? 100 new customers approached for a loan. What is the prediction? Out of this 100, see that if 30 people have got X features, 30 people have got X features, and out of this 100, 70 people have got Y features. What is your understanding based on this? Respond. 30 people have got X features means to approve the loan or reject the loan.
Paying regularly.
30 people got X features means people with X features, they are paying regularly. The history of the data is saying that they are paying regularly, they'll pay the loans regularly. So approve the loan for this. And people with Y features, 70 people with Y features, people with Y features, the previously saying that they are not paying the loans. Reject the loan. So machine here, what did you observe with this example? Machine learning is an approach to train models. It is an approach to train models. Before training doesn't have any knowledge. Model doesn't have any knowledge. But after training, model fit. Model acquires knowledge. From the data. See, before training, model doesn't have any knowledge. After training, model fit, model acquires knowledge from the data. Here, what the model learns? It learns patterns. It learns the patterns from the data. So it is going to learn the patterns from the data. What is the pattern involved in this data? performs prediction, classification. Once model fit, that has to be tested. Once model fit has produced, that has to be tested. Once model fit deployed into the application, once model fit deployed into the application will become a smart application. What is the difference between a normal application and smart application? Normal application and a smart application. Smart application. Normal application, instruction based. This one, smart application, intelligence based. Intelligence based. So generally what we do, train the model, model fit, accuracy testing, and deployment. We train model using data. The model acquires knowledge. Called as model fit. We perform testing. For accuracy measurement.
Can I ask you one question here?
Yes.
See, let's say you train the model using 10 data, okay, 10 data, okay, and model acquire the knowledge. So you deploy that. So when you train the model with the 10 data, but when you perform the testing, you use the trained model data, or you use the different data, or you have a 20 data, boss. 1 to 10 you train, and will you use 1 to 10 for testing, or 10 to 20 for testing, which is not trained?
See, what is train set, validation set, test set? We'll be having 3 types of data sets.
Can you explain that again? Can you write down here? Can you explain?
See, train set, validation set, test set. Train set. Okay, 1 second. I'll write it here.
Okay.
In a simple way, we got 3 types of set. Train set, validation set, test set. 3 types. Train set, validation set, test set. In a simple way, if I want to make you understand, I'll give a labor example. For example, a teacher, okay, for example, a faculty teaching the entire course, for example, BTech, a particular subject, faculty teaching, or like, for example, 8 units are there. 8. So that is what he gives the training. He gives the training, right? That is what train set. Train set. Validation set means simple. In a simple way, what I will say, for example, tomorrow there is an exam. I'm giving some important questions. I'm providing you some important topics or questions. I'm giving some important topics or questions for that exam. Test set. So that is your set on which you are going to apply it. So train set, the one which you have given the training, and validation set is just like some random sample set, you can say. Samples, you can say.
Random sample set from the 8 units?
Yes.
Okay. So maybe out of 8 units, you'll say validation like 1, 3, 5, or 6 is a validation.
So some subsets, you can say. We can say like just like a subsets.
Okay. What is test?
So, but later test set is the final set on which you are going to apply. For example, so here, observe in the previous example, if I take this, 1,000 customers are there. This I can say train set. This is 100 is the test set. This is what a train set. This is what 100 is the test set. On that we are, this 100 is the test set.
Okay. What is validation
So,
sets?
so,
In the same example, can you show me validation sets?
okay. For example, in this example, this Titanic is there. 1,000 passengers are there. This 1,000 passengers is the train set, right? In that, dead is 800, survived is 100, 900 totally. This I can say validation set. Out of 1,000 passengers, this is the train set. 800 plus 100 is the validation set. This unknown status is test set. Understand carefully. This is train set. This 900 is the validation set. And this 100 is the test set.
But this, see, out of 800, 900, totally 1,000, but you, that 1,000 data, you already been trained with the thousands, correct? That means that you are taking the existing
the
data only.
1,000 from the 1,000, we are validating this 900 only. Here 900 only you are validating. 800 you are taking the features of this, and this 100 only you are validating. On how you are taking the features of this 800, say X features, the 100 you take Y features.
Okay.
Understand? And this for the 100, you are just no need to predict the unknown status. Of 190 has got X features. So this is just like an overview I've given, but there are a lot of other things you need to understand, but I'm not discussing as of now. Fine. Here we train the model using data. The model acquires knowledge. We call it model fit. We perform testing, accuracy measurement. Later we deploy it into the application. So here we two things you need to understand. Here two more things you need to understand. Overfit, underfit. What do you mean by overfit, underfit? Any idea about this overfit, underfit?
No idea. Over means above and under means below.
So no name itself saying, right? For a labor example, in a simple way to make you understand, right? So just now I'm not entering into the technicals as of now. In a simple labor example, I'll give. Overfit means, for example, you are, you are organizing a birthday function. You are organizing a birthday function. You are arranging all the food and everything for that. For you are expected, you expected 500 people. You expected 500, but only 400 attended. Only 400 attended. This we call overfit. You expected more. Even the prediction of this result, you expected expectation more, but attended only 400. Underfit means you expected only 300 people will be attending it, but 500 attended. But 500 attended. Okay, overfit, expectation is more, but less you got. Underfit means you expected less, but you got more. Okay, so these things, just as an overview, I have provided this. So just I was briefing you about this data science, AI, Gen AI, machine learning, and how this happens. And just I was briefing you about in the yesterday's session, just I was briefing you about the course overview, what we'll be discussing as part of this course. 1 second. So here the language we use is Python. Python is this, it has got a lot of modules it is providing towards this data science and AI. Python has got thousands of modules. Python has got for different environments. For data science environment, see, Python is providing 89,300 inbuilt modules for different environments, for data science, for big data, for all this data analytics, right? But for data science, it is providing models like NumPy, CP, Pandas, Matplotlib, CP, like in this way, many modules, Python modules, right? Even PySpark is a module of Python API to use a Spark, right? So in
And
this
nowadays,
course,
instead of using the pandas, they are using PySpark, correct, for creating the data frames.
yes, yes. Pandas is used and this PySpark is used. PySpark is for data processing we'll be using, right? So PySpark data frames and this pandas data frames. PySpark is something like in-memory computation, right? Spark execution is will be very fast. So if you see both of them, the data frames will be almost similar. Okay. Introduction to Python, data analysis using NumPy and Pandas, data visualizations using Matplotlib, and statistical analysis for data science, machine learning techniques, deep learning techniques, NLP, test series and time series analysis, MLOps, big data, TensorFlow, Boltzmann machine, GAN or NN. See, in this, if you observe, right, for AI, we have got a lot of techniques, especially that deep learning techniques are mostly preferred, right? So in brief about those deep learning techniques followed by this. So generative AI, prompt engineering, advanced prompt, LLM APIs, RAG, vector databases, LLM ops, agentic AI. Once you check with this course content, right, and get idea about it.
But
So data,
what is the long chain and long graph and hugging face? All this comes under agentic AI.
yes. Data, so just check with this course content, have a look about this course content. In brief, in depth, we'll be discussing about this convolutional networks, Boltzmann machine, generative and emotions and gender detections, RNNGRU, LSTM, OpenCV. See, from module number 20 onwards, we'll discussing about generative AI and this agentic AI. Prompt engineering, advanced prompt techniques, LLM APIs. Here you can see building LLM apps in long chain, RAG systems, vector databases and embeddings, building end-to-end Gen AI applications, multimodal LLMs, LLM ops and evaluation, agentic AI, working with long chain, building AI agents, RAG systems. This you can check it, right? In brief, in depth. That's why I'm saying the course duration will be 5.5 months, right? So yesterday I was discussing 1 second. Okay. The offerings from my side, right? You will be getting the session videos, each and every session video you will be getting. Even if you miss any session, you can just go to the recording, attend the next session for better understandings, right? Yes. Soft copy of this class notes, clear notes will be provided of this, and assignments and tasks to work. A WhatsApp group you'll be getting. You will be added to the WhatsApp group where you have discussion with me directly, and live interactive hands-on sessions. Duration 5 months. So I said first 1 week it will be at 9 a.m. Later it will be at 8 a.m. And also apart from this, from DurgaSoft side, right, they'll be providing to have good command on this Python. Anyhow, I'll be discussing about Python, but still, if you want in brief knowledge on this, means 100 plus videos of Python will be provided, and MySQL videos for database and Unix, Linux shell scripting videos will
If
be
you go
provided.
100 videos will become a mad.
So that's no. If they'll be providing, that is up to you. It's okay. So, but I'll be discussing how much knowledge of Python required, everything. That knowledge I'll be providing in this course. How much Python knowledge required, right? As part to understand that I'll be providing in this course. That is enough. But still, this is an offer given by you, but that is up to you, right? So, from tomorrow onwards, the link is going to be changed. You are supposed to get enrolled. From tomorrow, a WhatsApp group will be created. You will be added to the WhatsApp group. From tomorrow, you
Tomorrow
will be
onwards is
getting.
8 o'clock or 9 o'clock.
So first 1 week it will be at 9. 1 week. Tomorrow it will be at 9 only. First for 1 week
Why?
it goes at 9.
We could continue with the 9 o'clock only, correct?
So here that is clearly said, right? Before you go with this payment process, for the 1 week it will be at 9. Later it will be at 8 a.m. Okay, fine. This is clearly
And
said.
you guys put me in the confusion mode.
No. See, one thing, after you payment, if you are changing the timing means you can, but
Oh,
before you
I
go with the payment,
understand. See, when I saw the class, it displayed me as a 9 a.m. So then I planned for the same class from the same Durga in soft. I planned another class. So now it's conflicting. Now it again. I So
See, okay,
it's
and I understood, right? Understood, but these are that given by this DURGASOFT, they'll be announcing that batches and timings. So trainer has nothing to do. Trainer is just going to just train. And if you got anything technically, you can ask me. But about the timings, visas, everything by the DURGASOFT, right? Fine. About the train timings, fees, everything. You can see in the Zoom chat, right? A big message is given by this online team, the DURGASOFT team. So you can see that contact details of this online team. Contact details of this online team is provided. Some four contact details is given. The payment details is provided.
so this
And
1 week, this 1 week is 9 o'clock.
this 9 o'clock, yes.
When I say 1 week means till Friday.
Today is Wednesday, right? For more 4 5 days, it will be at 9 o'clock.
So from Monday onwards, it's 8 o'clock.
Mostly from Monday, it will be at 8 o'clock.
Because you need to confirm me exactly so that I can talk to other guy, so that I
From
can
Monday,
plan.
maximum from Monday, it will be at 8 o'clock.
Okay.
So, and once again, right? Classes will be from Monday to Friday, but some Saturdays and Sundays I'll be taking. And even especially like the prerequisites like Python for these things, if any extra classes required, I'll be taking extra sessions. I'll be pre-intimating if you people with the timings, if you're okay with the timing, just I'll be taking it. Timing first 1 week 9 a.m, later it will be at 8 a.m up to the end of the course. There won't be any change in the timings, right? And already I said, if we talk about the job, already there is a high boom for this data science and AI. Total world is moving towards AI. Lot of job opportunities in this data science and AI. So just if you just this is the right time for shifting to this career wise, if you want to see, like even if you want career wise, if you see, and even is a package aspect also, right, you will be getting higher salary packages. So as there is increased demand in data science, and the if you see the pay scales also, highest salary packages for this data science AI engineers, right? Fine. Even companies, they are interesting, there are a lot of requirement today in the AI, data science and AI, right? So this course will have combination of both, like your complete data science and this AI. So AI engineers has got a great salary packages. Most of the companies are looking and with high paying jobs to this data science and data engineers. Already there are many career opportunities available once you do with the course, right? Like a data scientist, ML engineer, AI engineer, Gen AI engineer, even some features, if you add some more things, you add like data analyst, you can go. Yes. Fine. So these are the things, right? So tomorrow the link will be changed. You are supposed tomorrow the class will be at 9 a.m. only, but with a different link. The link will be changed. Suppose you are supposed to get enrolled for getting the new link, right? Yes. Um, yes. Any other queries you got, anyone? Right.
Thank you, man. I appreciate that.
Fine.
Thank you. Look forward to be part of your class. Thank you.
Fine. Okay. Fine. Thank you all for your time. Thank you. Meet you tomorrow. Bye.